So we're gonna continue where we left off. So let me just go back in time a little bit. And I kind of rushed through this one, and I apologize for that. Sometimes that happens. So if you just try your best to stay with me. What happened was that we were given a system. System is anything that is more than one, right? So more than one inequality, now you're doing a system. Remember this, as soon as it's a system, we use reverse shading. Because if you use regular shading, it gets very difficult to find a solution region, especially when you have three. Okay, reverse shading, you're basically shading away the areas that we don't care about, and you're left with the area that's true for all of them. Okay, so basically we take them each individually. Notice that when you're given, you have one variable here, one on the other side. I don't know if you noticed, and you might think it's too much work, but I actually bring both variables to one side, to the left, and then I find the intercepts, and then I go back and rearrange. And there's a bit of a reason for that. It's probably the fail-safe method of doing these. So that's what I'm doing. So when it's not looking like, standard form, I bring both variables over. X and Y, it doesn't matter which one you have first. I tend to put X first, then Y. And then the constant, if there's any number, I bring it over to the right side. So that's kind of like my first go-to. Find the intercepts. Why am I so focused on the intercepts? Because these intercepts will down the road be in the hundreds, maybe thousands. Don't be scared, but I'm just saying your window on your screen, right, will have to be adjusted according to these, right? That's why I'm doing that, and it's easier to graph as well. When you have your intercepts, you just go with it, right? And then you have your slope intercept. Why am I making you do this? Because you're going to have to type them into your calculator to find the final point, like the point of intersection or many points of intersections. That's why I make you rewrite. And once you have it rewritten, you know exactly where the true region is, right? Just by looking at where it's pointed. So trust me, this is like years in the making, this system. And it's pretty, after a while, students are pretty successful at it. So you just have to practice. That's the only caveat here is you need to practice, or else it will not work. You will come in, you'll be like, I kind of get it, and then you'll freeze, and time will go by, and you'll have no graph, right? Because you're so like, I don't know where to go, right? So you need to practice. Learn math by doing math. So let's do a few more systems here. This is example 2. So let's say I give you, let's just cut to just the inequalities. Okay, I'm not going to give you the scary looking like I did yesterday with all the commas and squiggly brackets, because in my questions I don't really do that, but the textbook does seem to like that. So if I were to give them like this, let's start with something that is perhaps not going to be a lot of work. This is actually a fairly easy system to graph. So when it's not too much work required, I sometimes just go to the side, right? So based on these, I can find the X-intercept, right, and the Y-intercept. So I want to use up the space, right? And so when X is equal to, when Y is equal to 0, you end up with this, right? It's 2, 0. And on the other side, Y-intercept, you let X equal to 0, so you're really just left with this. So I can guarantee you this. If it's just X plus Y, like no other coefficient, and a number on the other side, it will always be the number 0 and 0 that number. I don't know if that makes sense. Right? So if this had been 10 here, it would have been 10, 0, 0, 10. And so done. You're done there. let's rewrite it. I'm going to do that on the side here. So you're going to have to be, efficient with the space you use. I bring the X over and there it is. And at that point, I can say that this is going to be a solid line. The true region lies above, right? Because it's greater than. I'm going to shade below. So you will notice that if the arrows are pointing the opposite way, you know that I'm using reverse shading, okay? Then this one here, this is a vertical line. So there you don't have to find the intercepts, right? It's a vertical line through the 0.40, to be specific, right? And so I'm just going to say that it's going to be dashed. The true region is where? This one is left or right, not up and down, right? So X is less than, look at your study sheet, less than, it's to the left. So I'm going to shade to the right. And the numbers are pretty small. So I need, if I have this going 5 in each direction, I'm going to be able to make this work. Okay. So let's go graph this real quick. So as I said, I hope that by the time you get to grade 12, you're really good at graphing. You just know what to do. Yeah, Ms. Yosik, Mr. Erickson, they might do things slightly differently, right? But overall, it's going to be the same. So X, Y, they're going to look for the same things. And if you just make marks like that without labeling, I'm just assuming that you're going up by 1, okay? If you're going up by something other than 1, you need to tell me somehow. Label every second one or every fifth, just letting me know where you're at, right? So 1, 2, 3, 4, 5. I'm just going to do the courtesy of letting you know anyways. 1, 2, 3, 4, 5. And 1, 2, 3. I'm just going up by 3 there. And that's good enough. Maybe I'll label here -2 and up here 2, and that's so you're still telling me that your scale is 1, right? And now we're going to make this graph. So 2 zeros right there, 0 2s right there. Focusing on my first line there, it's going to be a solid. So that is my boundary line, and I will label it right before I do anything else because I tend to forget, just like you probably will forget too if you don't do it right away. Arrowheads, boom, boom, right? And then the vertical line through 4, 0 because it's +4. So right here, and that one is dashed. So make it very obvious that it's dashed, right? This is the line, X is less than 4. And so the reason, like they're not, I would say this is a pretty easy entry level difficulty in terms of systems. Okay, there wasn't a whole lot you needed to do here, but you always want to tell yourself before you graph what's happening, right? So you're not making a mistake later on. All right, so here I'm supposed to shade below this line. So I'm going to grab my ruler and start shading. And I'm shading the false region, all right? So it's almost like I'm getting rid of what isn't going to work. Okay, so look what I go along that line as far as you can, just shade everything underneath it. And the vertical line we're shading to the right. So you line it up with that line and then you go to town. You don't have to press too hard. And even if you go over your labels, right, as long as it's like a dense shade, you're fine, but it doesn't need to be extreme. Now I know that this is the solution region. This, any point inside here would be considered a solution. What about if I'm right on this line? Is that a solution? No, because that's a dashed line. So as soon as you go a little bit in, then you're good. On this line, you may be anywhere on this line if you wanted to, but not on this one. So this is my solution region. I label it. And we need to find the point of intersection, which I'm totally fine you just stating it on the side. And how many points of intersection does this system have? The answer is just one. There's just one point of intersection. The axes do not count, right? So if there had been a third line going here, now we're talking, then we would have more, but right now it's just one. So let's go ahead and find it. You can find that. So you grab your calculator, you go to y equals, clear whatever's in there. And I'm going to type in negative x plus 2. Do you remember how to graph a vertical line? I don't know if you do. You can do it that way, but this is how I will do it. So I've just graphed this. And I should probably go zoom 6, right? If you have any window issues, zoom 6 gets you back to the standard window, and that'll do it for us, okay? I need to figure out, right, when x is equal to 4, basically, go back here, we know x is going to be equaling 4 because on this particular point, x is equal to 4. No doubt about that. So we're going to go second trace 1, and then it's asking us what x value would you like me to find, and I will hone in on the 4, and there it is, right? 4, negative 2. Sometimes it's a decimal, sometimes it's an exact value. Negative 2. How did I find that? I went second trace 1, x is equal to 4, right? And then y is equal to negative 2. That's how I found that. And I don't know if you want to make an arrow just going that's the one we're finding. You don't have to do that. Some students like to label it right on the graph, but I prefer it on the outside because sometimes there are many and it just makes it very crowded. Round to 2 decimals if needed, okay? Okay, let's do the other method. This is a newer method. The other one would be you graph the vertical line, which is you have to go 9 nines. Okay, type in 9 nines like that. And then you go bracket, open bracket, and then you press the X variable button, and you have to enter the opposite sign. So let's say it's positive 4, right? X is positive 4. You have to type in minus 4 like that, as in like subtract. Close the bracket. And then when you hit graph, it's going to look terrible. That line is not going to look like a vertical line, but it's not bad. Sometimes it's very pixelated. But see, now you actually graph that vertical line. And how do you find the intersection between two lines? Second trace 5. And because it's only 2 lines, you can close your eyes and just press enter 3 times. There it is. 4, negative 2. It's up to you how you want to do it. Either method will work just fine. Let's do another one. And I'm going to up the difficulty a little bit. Okay, so 3. I'm going to spread them like this. I'm going to tell you that the first one is x plus 2y is less than 6. And the other one is, I'm going to do this on purpose, okay? Throw you off a little bit. The second one, for some reason, students have a hard time grasping that one. So don't fear it. Just follow that example, and when you see it, just apply what you know about bringing stuff over. Okay? So let's do this one first. This one is exactly how I would like it to be. You have x, y, and a constant. So let's go ahead and find the intercepts. This should not take you that long anymore. Okay, so I'm actually going to rush through it. X is equal to 6, so it's 6, 0. And then it's 2y equals to 6, divide everything by 2. Y is equal to 3, so it's 0, 3. Okay. And by the way, these questions are, like, I've never seen these before, right? So I'm actually doing this live with you. So, like, I don't have a key, right? So I want you to kind of know how I think through it and how I solve it, right? Which can go sideways, but usually it works out. All right, so let's rewrite it. 2y is less than negative x plus 6 divided by 2. Y is less than negative 1/2 x. That's kind of how we like to write it. And it's negative, right? Plus 3. And it jives, right? 3 and 3. So we have confirmation that what we're doing is good. And so this is going to be a dashed line. True is below, shade above. We're done there. And now this one. So this is one way of doing it. I'm going to bring the y over just so you see that. So it's going to be x minus y is less than what's left on the other side. 0, right? Okay. And so I just want you to see that that's what you can do, right? Don't fear it. And so let's find the intercepts. I can tell you already, what is the intercept going to be? 0, 0, 0, 0, right? So x is equal to 0, so 0, 0. That's also called the origin, right? So here on the other side, you have negative y is equal to 0. If you divide both sides by negative 1, y is still 0. So it's 0, 0. So this one doesn't help you a whole lot. And I will show you how to get around it. So the x-intercept and the y-intercept are the same. It's actually going right through the origin. So you have a bit of an issue there. There should be a comma, by the way. But I will help you with it. So let's rewrite it. So I'm going by this one here, okay? Look up carefully. The negative y stays there. The x comes over, subtracting. You can do plus 0 if you want, but it's not going to help, right? What do we do now? Divide by negative 1. What happens to the symbol? It flips, right? And negative divided by negative is positive. You're like, whoa, right? Can I just take you up to the original? You could have just flipped it. Just flipped it and just make sure which way is the symbol. It's opening towards the y and it's still here. But I did it in steps so you could see that that's actually the case. This is what we want. And then you go dashed, true is above, shade below. And look at this. The symbol is this way, less than, and we're shading above. Here the symbol is the opposite way and we're shading below. So that makes sense. Okay. You think I'm going to fit the graph in here? Let's try it. Let me just think one moment here. 6003. Yeah, I think it's going to work. So what we're going to do here is kind of focus a little bit more on the, watch, I'm going to offset it a little bit. So this is my y-axis, but I'm going to focus more on the positive side of the x. So I'm just going to go like this. Okay. That's fine to do that. So x and y. So I need to fit in that 6. So 1, 2, 3, 4, 5, 6. I'm going to label the fifth one like that. 0, 3, 1, 2, 3, 4. I'm just going to label 2 here. That's fine with me. And as a courtesy, I'm going to go -2 there. Six zeros right here. 0, 3 is right there. Let's make that line. I'm not too happy with this, but I think it'll work. There's nothing wrong with this, just so dashed line, right? Let's label that real quick. Y is less than -1/2 x plus 3. And the other one. Let's copy this down first. I want to make sure you're ready for the next one because that's the tricky one. When the y-intercept is 0, it is a problem. So you have a couple of options there. All you do is look at this chart here and then go back to the original here and just say this: any random value will do. But say when x is equal to, let's say we want to know like x equals to 2, right? What will y be equal to in this case? 2 as well, right? Right? So a second point is 2, 2. So you're basically creating a second point because you can make x equal to anything. Right? If x has been 3, y would have been 3 as well. 4, 4, 5, 5, and so forth. But within the scope of my graph, 2, 2 is right about there. And we know that the origin is also part of it. So that was our starting point. Now we found our second point, 2, 2, right? Let's, that is also a dashed line. So it looks like the point of intersection will be 2, 2, but we're not too sure about that. Got that? Y is greater than x. And now let's do the shading. The first line we're supposed to shade above. Take a ruler and just, we're shading the false region. Let that be known, right? So that is not part of the solution, gone. The other line, we're supposed to shade below. So we're gonna go to the other line and shade below. So again, you're just doing them one at a time, and it shouldn't really, right, be a big deal. So this here, it just gets bigger and bigger, right? If you continue further to the left, but that whole thing here is considered the solution region. Both are diagonal lines. We suspect that the point of intersection will be 2, 2, but we're not quite sure. So this is where you find you go to your y equals, and let's type that in real quick. Bracket -1/2. I would encourage you to do that too, just to make sure you're going through the motions of typing things in and you're doing it right. You don't have window issues, anything like that. The other one is just x, right? Just yx. Y2 is just x because that's the only thing that's on the right side. Hit graph. Most of the time for now, a standard window will do the trick. And you kind of want a confirmation that your graph kind of looks like the one right on your screen. And then we go second trace 5, enter, enter, enter. And it is 2, 2, right? It happens to be 2, 2, but I don't want you to guess, okay? So the point of intersection is 2, 2. So this is, right, very important. This one is really this point right there. And I'll do the same with the one we did before. If you want to highlight, right, that is this. Obviously the arrow is pointing to it, but quite often students forget to find the point of intersection, right, to be completely done with it. Let's do one more. And I want to throw one in there with 3 inequalities, but I'm not so sure yet if you're ready for it. How about this? Before we continue, I'm already going to give you the homework in case we run short on time. So page 317 in the textbook, yeah, you're going to have to blow the dust off, right? Because you haven't used it in a while. And I picked questions specifically for you to practice. So 2, 4, 5, and 7. I looked at the answer key. The book is confusing at best when it comes to the answer key. So I will make an answer key today and post it. Maybe I might even make a video as I make it. And if you want to look at it through the video, then you can kind of see, oh, okay, now I get it, right? So because I get it that this is somewhat new to you. So make sure, you might think, oh, there's only 4 questions. Like question 4 has like 3 systems to graph. So let's say you're tight on time, you have sports, you have other courses, right? I get it, but you gotta practice like at least, you know, a couple until you're quite comfortable with it. Otherwise, you're gonna have a hard time, right? All right, because we're going towards word problems, right? All right, one more. 2x minus 4 is greater than or equal to y. I'm doing them side by side so we save some space there. 2y plus 3x is less than or equal to 7. And that's all for now. So watch what I'm doing here. I'm going to go to 2x. The y comes over negative. The sign is there. I bring negative 4 over to the other side. And then I find my intercepts. And this would be 2x is equal to 4. Divide everything by 2. X is equal to 2. Sorry. There we go. It's on record. All right. The other one is negative y is equal to 4. Divide both sides by negative 1. Don't forget the negative, right? Don't just get rid of it. Okay. So there are my intercepts. I have everything I need to graph. Take some time now to rewrite it. So negative y, I'm going off this one here. Because just remember, they're all the same. If you do it correctly, if you move stuff around, it's all the same. Then the 2x goes over negative, and the 4 is already there. Warning, right? Dividing by negative, warning, warning, right? Y is less than or equal to. Negative divided by negative is positive. 4 divided by negative 1 is negative 4. I know you did a lot of this in IPR, at least you should have. This is a solid line. The true lies below the line. So we're going to shade above because this is a system. And I'm going back to the other one. I'm going to add something at the end here. So this one is exactly the way I want it, so no manipulating needed. Okay? Sounds so evil to manipulate. Anyways, 2x, so I'm going to make the y, watch that the y is in front. I did that on purpose. I'm kind of messing with you a little bit, right? I'm putting stuff all over the place so you're not so used to it. So it's 3x, 3 and 7, that's not going to be pretty, is it? Nope. So when you're doing the intercepts, they're there for you to graph. I want you to do this, right? If you're not sure, right? Write it as a decimal. I'm going to round it to 2 decimals. So it's 2.33. So 2.330. It's a point, right? On the other side, we let x equal to 0, so it's really 2y is equal to 7. This one we can handle, right? That's going to be 3.5 exactly. So 0, 3.5. Don't dread the decimals, okay? So we have everything we need to graph. Now we need to figure out the shading and rewrite it so that we can enter it into our calculator. So 2y is less than or equal to, the 3x comes over negative, the 7 is already there, nothing happens to it. Divide both by 2. No flipping of sign. And watch this. I tend to leave everything in fractions here because sometimes it's a non-finite decimal that just keeps on going. I want all of that to follow me into my calculator. So I leave it like that. In this case, I know it's 3.5. So if you're wondering why does Mr. Dirksen keep it a fraction here but turns it into a decimal here, this is because we want to actually know where to put those points. And this goes into the calculator. This is a solid line. The true is below, just like the other one. Watch this, right? same pointing, so it makes sense that they would have the true region in the same area. I'm going to shade above. Intercepts for graphing, this for calculator and shading. Okay. And now the fun part, the graphing part. And right now, everything is small numbers, right? So if I go 5 in each direction for today, and most of the examples right now, because I don't want you to have to worry about that too much just yet. Okay, so let's make our graph, and I'm going to add something to it, okay? So right, X and Y is there. 1, 2, 3, 4, 5. 1, 2, 4, 5. 1, 2, 3, 4. I'm just going to label that one. 1, 4, 5. This is -5 down here. All good. Intercepts 2, 0, 0, -4. Watch, if I were to connect these, this line is increasing from left to right, so I'm expecting a positive slope. I'm just going to go check. Yep, I do have a positive slope on my line there. So that is important for you to check as you're doing this. So dashed line, no, solid, sorry. Solid line. I label it. Then I plot the other one. 2.33, which is right about there. It's not quite 2.5, right? And then 0, 3.5, which is right about there. It's solid as well. There's my label, 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 label. And now the shading. Shading above for both of them. So it doesn't matter which you start with. If you want to start with this one, it's above. And I'm shading the false area. And then you take the other line and you shade above that one. And notice that there is overlap, right? But I still go just to show, right, that line, everything there is gone. So this is my solution. Everything done except for the POI. So somewhere on the side, we're going to find that point of intersection that we're wondering about. Okay. So let's enter both of them. So I'm going to go 2x minus 4 and -3 over 2x plus 7 over 2. And I tend to do that in brackets as well. 7 divided by 2. And then the graph. There's the first one. There's my second one. It does look like it. And I want to... Did I tell you about the zoom in feature? I don't think I did. If you want to zoom into that, you can press zoom. And the second option says zoom in. And then you need to find the cursor on your screen. Like mine is, I don't know if you can see it. Can you see it floating there? I'm going to go closer to where I want to zoom in and hit enter. And it actually zoomed in a bit more. If you want to zoom in even more, just go closer to that intersection, hit enter again, and it will keep on zooming in as far as you want. I don't use this very often, but I think it's a neat feature. So that's the point you want, right? So then we go second, trace 5, and you hit enter, enter, enter. And as I expected, that was going to be an ugly number, but we can handle it. So where is it here? 2.14, and the other one is 0.29. No problem at all with decimals, except in some cases when this represents like number of, snowboards and something else, then we can't have it. Then we're going to have to round down the road. Okay. One more thing here. Is 5 -3 part of the solution? Is 5 -3 part of the solution? What would you say if you looked at graphically speaking? 5, 1, 2, 3. It looks like it would not be, correct? But when I ask you that, I don't want you to just guess, because it's either yes or no, right? Like it's a 50-50. I want you to show me. So you do this. You take both of the original ones here. Let's write the first one down. 2x minus 4 is greater than or equal to y. That was the first inequality. You plug in x and y into them. So it's 2 times x minus 4. Is that greater than or equal to y, which happens to be -3? You get 10 minus 4, -3. This happens to be 6 is greater than or equal to -3. Is that true? Is 6 greater than or equal to -3? And the answer is yes, right? So this checks out. So then you try the other one. I'm going to the top again. 2y plus 3x is less than or equal to 7. I like to use the original on this one. So then you go 2 times -3, that's what y is, plus 3 times 5. Is that less than or equal to 7? You get -6 plus 15 is less than or equal to 7. Let me zoom into that because some of you are probably squinting. And this is 9, right? Is less than or equal to 7. Is that true? Is 9 less than? It's false, right? So you need, in order for this point, 5 -3, to be part of the solution, every single inequality present needs to be true. All right? In this case, it fails. So therefore, not a solution. Sorry about that. So if the question ever asks you that, I want you to insert it. And you know what? If the first one you try is false, listen carefully, saving time. If the first one we had tried was false, done. No longer, you do not need to do the rest. As soon as one fails, it's not a solution because it needs to be true for all of them. Okay? That's also in your textbooks, so make sure you practice that.